Good morning, everyone. I was going to pre-record this, but I didn't take the time to uh, get everything ready. So here we are. Uh, I wanted to do some review since there isn't a test this week and I don't have to speed through the material or anything. I wanted to go ahead and review series circuits and then review parallel circuits and then oh, there it is. Okay. And then move into combination circuits because it's very important that you have a firm understanding of series and parallel before you get into the combination circuits. Okay, so all that said, let's get started. When batteries are connected in series, their voltages add. That's the most simplest way to say it, but you connect them in series because it isn't showing me a preview. I'm going to keep going while it thinks about it. I did go through all of the tests and mark down which questions people missed, how many of them, and stuff. And then I went through those and selected the ones that actually, carried weight. There were a few questions that a bunch of people missed and absolutely should not have been missed because they're incredibly simple and don't carry any weight forward. Alright. What is the total voltage in this circuit? So let's open up that picture. Open with paint. Okay, let's resize it to 500. Give ourselves a little bit more room. Alright, now we're ready. Alright, so in this picture, let's always need to resize the. Okay, in this picture you have several different things going on. But the main question is how much voltage do you have? So let's start there. So voltage flows in one direction in a direct current circuit. This battery is setting voltage in that direction. And this is like a racetrack. There's a path that goes around. So these two batteries are going in that direction around the racetrack. You could say that's clockwise. And these two batteries are going counterclockwise. If batteries are going the wrong opposite directions, they subtract from each other. So green has 36 volts. Red has 18 volts. They subtract from each other, leaving us with 18 volts as our answer. Again, you do not just strictly add them all up. You have to pay attention to what direction they're going in. Okay, next question is, what is the voltage across resistor R1? Okay, we have a circuit. Let me open that one up. That looks like it. That is. Okay, so let's resize. Alright. So in this circuit, we have several things, but let's go ahead and make our chart so we can do Ohm's law and keep everything nice and neat. R total, R1, and R2. I total, that's current total, current through resistor 1, current through resistor 2, and then voltage total, which we got 180. Voltage through resistor 1, which is what we're looking for. That's the answer to our question. And then voltage through resistor 2. Alright, let's keep filling things in. We were given 27 ohms. This is volts. 27 ohms and 18 ohms. Let me grab all of this. Move it a little bit further from the edge. That's good. Alright, so our first step, I'm going to use green as my figured numbers. First step is 27 and 18 added together. So that's 27 plus 18. That's 45. So 45 ohms. 180 divided by 45, that's going to be 4. Amps. Sorry, it's early. And since this is a series circuit, current stays the same throughout the circuit. So we have 4 amps and 4 amps in our circuit. So now all we have left to do is multiply across. 27 times 4, that's going to be 108. Yes, 108. And then, excuse me, 18 times 4. Let's see, 18 times 2 is 36. So that would be 72. And that fills up 108 and 72 adds up to 180. So that satisfies the voltage requirement. The voltage adds together to be your total. Oh, I'm losing my voice all of a sudden. So 108. 1 second. Let me mute my mic before I cough. All right. Didn't want to blow out y'all's ears, coughing right into them. Okay, what is the voltage across R1 for the circuit shown in the figure below? Given our total is 60 ohms, R1 is 8 ohms, and I total is 4 amps. Oh, this one's easy. So let's go ahead and open this one up. I believe it's right here. Yes. All right. Nah, it'll be fine. This one's pretty simple. Let me grab my numbers off the other page. R total is 60, R1 is 8, and I total is 4. It actually gave you way more information than you need. I actually need to make that smaller. Oh well, I'll keep going. What are all these other numbers? Doesn't matter. Because in a series circuit, current stays the same. Oh, I got out of order. And 4 amps. So, all of this is 4 amps. 8 ohms times 4 amps will give us our E of R1. We don't even need E total. We could find it, but we don't need it. 8 times 4, 8 times 2 is 16. 16 times 2 is 36. No, 32. Yeah. 8 times 4 is 32 volts as I run off the edge. So 32 volts is the answer to this one. 32 volts. Alright, the lamp in the circuit shown in the figure has a rating of half a watt and 4 volts. What size must resistor R1 be in order to limit the current through the lamp to the rated value? So let's open up the picture with the lamp, which is right here. Open with paint. That's good. Alright, so we have 9 volts total. So we will need to make the power row. R total, I total, E total, and P total. Then R1 and L1. I'll call it L2 just for simplicity. I1, I2, E1, E2, and then P1 and P2. Alright, so the lamp, which we have labeled 2, has 0.5 watts. Oh, that's a 3. Watts, and for volts, we have 9 volts total. And that's all the information we've been given. But if you've laid it out like this, you can see, well, these two add up to 9. You have 4. So what's left is 5. Okay, well, now that I've got all that, I've got 2 things on this row right here on the bottom row. If I take 0.5 and divide it by 4, you get 0.125 volts. Is that volts? No, it's amps. And since amperage stays the same in a series circuit, you have the voltage, the current. I say voltage, I'm sorry. Since current stays the same in a series circuit, you have the current throughout the entire circuit. Now, if you take your current and your voltage and multiply them together, you get your power. I want to say it's, got nothing. I can't remember. 0.125 times 5. 0.625. Which I think I did the math wrong when I created this question. Oh. I went and answered the wrong question. So let's go back. We filled in another spot. Not the spot we needed. Okay. So now we're looking for here. 5 divided by 0.125. And do the opposite thing of what I did. 40 ohms is the answer. Well, I was talking, something didn't seem right. 40 ohms. There you go. Alright, that has been all of the questions that I wanted to go over. I'm going to work up a review for parallel circuits in a moment. But in that time, I'll probably go live during this next stretch and do some parallel circuits for you guys. But I will put up a quiz right now with something else entirely. Alright. See, theory 04. This is a overview of combination circuits, and we will get into the intro to combination circuits just before lunch, but I do want to talk about series circuits so you guys can look at your tests. So I will go live again before. Alright. You guys go ahead and do this one. And I will see you guys in a couple.